This video is a presentation by CrashBang Labs, your Regina makerspace. In this featured video, the presenter Kriska will be talking about the current state and future use of 3D printers.
So Kriska is going to talk about kind of the current state of 3D printers and the future of 3D printers. So that's kind of how we ended our last topic, with what's the use of 3D printers and what's the future of 3D printers. Right? So when you're playing it's a nice lead-in to what Kriska is going to talk about. And so yeah.
How's everyone doing tonight? Nice and warm? I mean, it's better than freezing, right? No.
With that door closed, it's going to start slowly heating up again.
So, my name is Kriska. I have created my own and brought to market now my own 3D printer. I live in Regina here. I have an online store and a physical presence in Regina. Though it's not an outlet store, it's still a physical presence in Regina. For 3D printers, 3D printer filament, and 3D printer parts. So I've really tried to take the initiative to get something out there so that everyone can really experiment, see it. I'm doing computer camps this week and last week, and I'm trying to get out in the community so that they can see 3D printers in action. What I want to talk to you tonight about is kind of the history of 3D printers, where they came from, and where they are now. So it might be a little bit intellectual. It might not be. We'll really see how it goes. But I'm really passionate about 3D printers and how they've come into existence, and kind of where we've come from and where we're going to go. So you can ignore the video for just now. We're going to watch a little clip in a little bit, just about the founder, the creator, kind of 3D printers. I wish this was a little bit closer so I can actually read my notes. But didn't I say anything up? Perfect. So I guess the roots of 3D printing actually go back to our roots when we were cavemen and we wanted to make tools and repeatedly make tools, whether it was basic simple knives to advancing into arrowheads, advancing into all parts of our human culture and humankind. We've had this desire to replicate things, replicate what someone else has even, and be able to either improve it or just use it in our day-to-day lives. Then we go through, we kind of went through some darker times in our history where there was a lot of very religious overtones, and we had Bibles come about, and Bibles were one of the first books that were replicated en masse. And back then, when you were replicating things, it wasn't as simple as clicking print on the printer or even going to a printing press. You had people handwriting out the Bible, just as you had people handcrafting columns. And I think if anyone's been to, probably not necessarily Regina, but anywhere that has some history, you look at the columns that they've crafted. Duplicate columns. Do you know how hard it is to make an exact duplicate of a column when you're using chisels, hand tools? It's pretty amazing. We had craftsmen back then to help us craft what we wanted, what we wanted in mass. And so we had craftsmen and tradespeople to make sure that we had the skills available for people to keep making things and making duplicates of things and improving our society. Sometime in the late 70s and early 80s, we had a gentleman, Charles Hall, came about. Now, has anyone ever heard of Charles Hall? Okay, good. Well, he's the grandfather of 3D printing. Everything goes back to his original patents in 1986, when he pushed through a patent basically on 3D printing. The patent itself was the first patent was for the idea of 3D printing, so replicating an object using a thin process layer. And then the next patent that he pushed through was using the actual very first patented XYZ coordinate system, Cartesian coordinate system in 3D printing. So you guys have looked at the 3D printer here and the 3D printer here. They both use a Cartesian system. Everyone knows what that is, X, Y, Z axis. So one axis is X, one axis is Y, one axis is Z, usually up and down. Really, you can do it any which way you want. Charles Hull was the very first person who did that. And he patented it right away, because why wouldn't you patent something right away if you want to get the money from it? The problem with him patenting it right away is that other people saw this, wanted to copy it, and started immediately. A little company called Stratasys immediately started up shop and started making patents on similar objects. So you got two people in the late 80s, early 90s patenting the crap out of everything. So Charles Hull developed, made a company called 3D Systems. Has anyone heard of that?
Yes.
Yes? No? Maybe? You know what? You're here to learn. It's fine. So 3D Systems has been the powerhouse of 3D printing up to when the first patents expired, really, because these two patents came about. It locked down the whole infrastructure, so that no one could make 3D printers. No one wanted to make 3D printers because they weren't letting them make 3D printers. The patent system kind of just locked all the process and development down. Very first 3D printer that came out, a lot of people don't know this, it was a laser sintering printer. 1987, I think? Let me just check my notes here. 1987, yeah, 1988, so the very first printer came out was a laser sintering printer. Now, I don't know how much you guys know about 3D printing. Laser sintering printing is one of the finest arts of 3D printing. You can get very smooth objects, like very smooth objects in a laser sintering printer, because it slowly pulls it out of a gel. It does it like very small layer levels, and you get very precise action. But since we couldn't, because this technology was patented, something called fused deposition modeling came about. Fused deposition modeling is these printers right here. So they spit out a tiny little bit of plastic, layer by layer, 100 microns at a time, 200 microns at a time, slowly building something up. The drawbacks is you get little bumps and little ridges, because it's basically a hot glue gun going around in a circle or going along in a pattern. You don't get a smoother, prettier quality. What you do get now out of fused deposition printing or fused deposition modeling is you get your choice of filaments. So I'm sure up to this point you've all heard about different filaments that have come to market. Has anyone heard of NinjaFlex?
Yeah.
So I'm with Canada's first representative of NinjaFlex filament. You can now get it at a couple other sites, but I was the first one to actually bring it into Canada and start selling it. So NinjaFlex is a fully flexible filament, so you can literally have bendables. Nylon, has anyone heard of nylon filament? Nylon filament is a super strong filament that it's like farm grade filament. It's what you'd see farm parts in. So I've been working with a customer who's wanting me to develop replacement parts for a combine and a seeder built out of nylon. So there's like a joiner part in between the seeder hoppers that hold the actual rod in place. I'm helping print those out for him in nylon right now. Nylon's super, super strong material, and it's already used. It's like the replacement parts that he needs are in nylon. So exactly what he needs for what he wants. ABS filament, everyone's fairly familiar with that. PHA filament / PLA filament. ColorFab released a combination filament called PHA. It's a PHA / PLA filament that basically is a combination filament with the goal of having super precise filament rolls. For that, you can have a 3D printed model that is maybe not quite as good as this, but really it's getting really close. So because the layers bond so much better, because the filament is of the correct size and constantly of the correct size, you end up getting an end product that is basically like touching a glass surface. So Yes.
Is PHA still making renewable resources and is it still biodegradable?
PHA is biodegradable. It's not as biodegradable as PLA, so it doesn't break down quite as quickly. It's within like, I think it has a 20-year lifespan, so it lasts a little bit longer. Still biodegradable. It's kind of the next gen filament, and it's really popular overseas. So overseas, it's gone large. Here, we're just getting into it. It's okay, I didn't need notes anyway. It just has a lot more boring facts on it. So I had this really nice presentation prepared with like patents that have gone through and court cases that have happened over 3D printers. Does anyone care about that, or should I just kind of touch more on the printers itself?
I think you should look at the future more than anything.
Oh, well.
We kind of touched on a lot of stuff with the last lecture on the kind of the theory of it, the G files and all that kind of stuff. I don't know, everybody kind of agree on that, or what do you guys think?
I wasn't actually going to touch any of the coding, so.
Yeah, I'm kind of interested in it with the legal stuff.
Okay, so it's basically been an absolute patent war with 3D printers. Now, us here in Canada, we don't, everything here is like literally lags behind 10 years. It doesn't matter what we do, our cars, our exchange rates on our money, everything for whatever reason lags behind 10 years. So we've just been watching this patent war ensue in the States. Patents that have recently come off. 10 years ago, we had our first fused deposition model patent been removed. And then you see in 1996, we have the very first launch of the RepRap project, which the RepRap project got one of the very first open source 3D printers on the market called the Darwin, that I'm sure probably no one's heard of, but it led to the Mendel. It led to pretty much these 3D printers. The company that started these 3D printers took basically all the community documentation, all the community information, and made a 3D printer out of it. They just collected all the information that was made free into the public and made their own 3D printer. So the MakerBot was released in 2010, I think, 2009. I have it in my documentation. But the really important thing about the future is that where we're going is back to a process that was originally pioneered in 1986 called SLS, or laser sintering technology. And people are very excited this year, specifically for 2014, that we are going to see these explode off the market. Why are we going to see these explode? Because the patents are ending. Some of the main patents that have been keeping this technology out of everyone's hands are expiring this year. So you should start seeing them probably hit the shelves, hit the stores in November, because I do believe the patent ends October 31st.
So is this going to change things? These older have a patent one? Like what's
Okay, so that's a awesome. I'm glad you asked that. I'm getting chills right now. MakerBot, which we've cherished because they took our RepRap and they made it into something. They started selling it, it went consumer grade, and they opened it up to the public, and they got people involved and people active, and people buying printers just got bought out by a company that doesn't want to do that. So they, it's kind of the big boys control the world scenario. So when I know you might not think this is referring to laser sintering technology, but give me a minute. So the big boys now bought out the one company that the whole world has latched on to for fused deposition modeling printers. They are now marketing it and pushing it out, and pushing out the message to everyone that we need to make fused deposition modeling printers, what everyone uses in their house, not laser sintering printers. So they are trying to push a message that you don't want to do laser sintering technology. The kind of the corollary is, for the last 2 years, everyone has known that the patents are going to expire on laser sintering technology, and they've been predicting up until 2 months ago that it was going to be a game changer, that we were going to get 3D printers in the house. They would be $500. $500 for a full-size printer, not like a peachy printer where it's like the size of a cup. You would see actual laser sintering technology printers, big scale, in the houses, so you could print off anything you wanted. Yes.
Sorry, maybe you could, maybe, I don't know if you spoke about this already, I think maybe you did, but could you reiterate, is the laser sintered printer better, or there's trade-offs, or what, like what's better?
That's awesome. Well, okay, so I didn't speak about this because I was going to be getting to it, but we can definitely cover it right now. Laser sintering technology, it's finer, it makes beautiful objects, so you will see this like beautiful chess pieces. It'll make no problem, print it off, looks amazing. Right now, or before the Form 1 Labs came out with their special resin, you used to have to UV treat your parts. So once it was printed off, you take your part, you take it over to a UV machine, you put it in for a couple hours, it would harden the plastic properly so that you could actually use it. Now with Form Labs, you don't necessarily have to do that, but it still helps with the finished product. The problem with the trade-off of using fused deposition to laser sintering is that fused deposition is stronger than laser sintering, and fused deposition you have more options now because the technology has been open for the last 10 years for people to develop it. So when I was talking about those filaments before, nylon, flexible filament, PLA, PHA, we have a PVA, which is like a water-soluble type, so you can do bridging in water-soluble filament. We don't have any of that in the laser sintering, but it's fully expected once it does become open source, you are going to see a leap forward in what materials you can use. Because right now, one of the holdbacks with printing itself is that for years you could only print rigid objects. Well, that's great. Rigid objects are great. Like half my house is now 3D printed right now because, I have custom solutions all over my house and pretty solutions. Like I don't have to be limited by just going to Walmart and getting that standard hook off the wall or getting a water faucet, a special faucet, or getting a kid's play toy. I don't have to be limited in that way, but I'm limited in what I can print with. I'm limited in what it's going to feel like. So I'm not going to print something that my kids are going to get upset or get cut on because I don't want them to be hurt, right? The NinjaFlex filament is in the process of becoming the world's first FDA-approved filament because it's such a stable compound. Very little chemicals are given off even after it's been printed with. It's going to be one of the first food-safe 3D printed filaments in the world.
Can you combine the two, the non-flexible and flexible together?
It depends because yes, you can do it separately. Like you can, people use flexible filament to print treads for go-karts, things like that, and then they slap it on a plastic tire, like a rigid plastic tire.
Right.
You can, if you have a dual-head extruder, you can automatically bond the two together right on there. But it's not. With everything, you have to make sure the temperatures are correct, right? So, any other questions? Yes.
I couldn't quite tell. Would you say that learning about this has left you with some rather strong feelings regarding patent reform?
I have some heated, I want people to be able to make money. And I realize the patent system is there for people to develop products and to make money for them. But when the patent system is 90% large corporations making money and everyone else just gets bullied, I take an issue with that. I have this anti-bullying thing inside me that I just don't like that. The 3D printing is it's like nothing. It's like every other business out there, whereas the big companies just want to keep getting richer, right? So Stratasys is the company that actually bought MakerBot. Stratasys is one of the original founding companies that started doing fused deposition modeling printing. So they kind of come from those roots. 3D Systems is the other big boy on the playground. They have what you know as the Cube out there right now. If you've ever been to Staples, the Cube printer is they're the first production line printer to the public. So I'll just check my notes here. Oh yeah, RepRap was first in England, just so everyone knows. It wasn't an American one. Okay, so where is printing going? Everyone excited? Okay, who's seen a 3D printer in action? Who's seen a 3D printer fail? Fail horribly? Catch on fire? It's one of those fun things. Where 3D printing is going is obviously the very first thing is going to be stability. So you're going to say goodbye to the 256 chip, the 2560 chip that everyone's known and love out of the Arduino, because it's not powerful enough to do what we want to do. Not to mention the fact that there's almost no safety on it as far as fire protection. I've had a printer burn up from that. So something that you're also going to be seeing actually right now is ColorFab has just released one of the first metal filaments. Bronze. It's a bronze roll filament. It has a low melting temperature bronze spec in it that once it's printed with is a slight, it's kind of like a faux metal, but it's still a metal printed filament. It just launched 3 weeks ago, and I should be getting some in the next probably month. Yes.
What is the melting point of that?
280, or no, sorry, 270? Yeah, it's 270.
Celsius?
Yeah. So it's a little bit hotter than usual. You might have to upgrade to a all metal nozzle. But it's kind of the future of where 3D printing is going, because really they've been able to do bronze 3D printing for a while now. If anyone's knows the process, they use a saturated sand to make the actual 3D printed model. Then they put the model into a furnace with chemically treated, or they chemically treated, put it into a furnace with bronze. Bronze leaches into it, sucks into the sand, and you have a bronze statue. So that technology exists, but no one really wants to have an oven in their house that gets to 2800 degrees. I don't know why. I think it'd be cool. I would have use for that oven. Yeah.
When you need that lasagna now.
Yeah, exactly. You need to get things cooked, it's there. So the metal is really where we want it to go, right? What you can do right now with a 3D printer, a Cartesian printer, is you can print in chocolate, as I think my predecessor said just before I came up here. You can attach a laser cutter, you can attach a CNC drill to it using a Cartesian printer. The two videos that I want to show you, one is actually going to be talking with the actual creator and inventor of the first 3D printer, and it's going to show you a little blurb about of their printer. And the second video is just a little blurb of a non-Cartesian printer. So someone made, I don't know if anyone's familiar with Delta Labs or the Delta Bot. They made a non-Cartesian printer, which is really cool. It looks, well, you'll see shortly, but it looks really neat. Okay.
Is it on the,
It is not on here.
let me take a look.
Okay.
My phone day.
Do you want me to? I've got a work hotspot.
Yeah, we need another Wi-Fi.
We don't get internet here until Thursday.
I have a worker on there. You need to?
Okay, so
That was around the
Is this the one that you want?
no,
That's the other
that's the other one.
Okay.
So you click back into the 3D Printing Symposium document. Yeah, go up, not that one.
Because we need a,
Let me.
my phone had a yeah, my phone shut itself off.
You need a hotspot or laptop?
I think he set one up.
Okay. If that doesn't work out, one hotspot. Might be the best.
What's that?
What are we looking at?
Three things. the
80s,
Wayback Machine.
Where's the speakers?
Are we plugged into the stereo?
No.
Can we reach over there? I don't know.
I didn't anticipate. Well, it'll be loud enough. It'll just be a little. Hold on. What's our cord is on the back side of this? I don't have
Oh, let's just fire it up. No, let's just fire it up. Okay. I don't want to take up everyone's precious time.
Seems kind of like magic, but it's called stereolithography. You dream up an idea, plot it out on your computer, and then presto, out comes an exact model. And science editor Michael Gillen tells us it's revolutionizing American industries.
Ever since the Industrial Revolution, we've learned to make things, lots of things, quickly and cheaply. Unfortunately, we're not as good at designing things quickly and cheaply. For example, the auto industry spends twice as much money designing car parts than they do making them. Well, that's about to change, though, thanks to a remarkable new invention called stereolithography. Here's how it works. Suppose you've just designed a new widget, in this case, a new and improved distributor cap for automobiles. Next, you'll want to make a prototype, a test widget, before going on into mass production. In the old days, the auto industry made test models out of clay, a process both expensive and time-consuming. But with stereolithography, this computer uses a laser beam to literally create an exact 3D replica of your design.
A good way to describe it is to call it a three-dimensional printer.
Charles Hall is the inventor of stereolithography.
In the broadest sense, you might say that the best origin in manufacturing what the Xerox machine or the word processor or both of those do for the office environment.
In stereolithography, the solid object is created out of a pool of liquid plastic. The liquid plastic hardens wherever it is hit by the laser beam, so that as the laser beam traces out the design, the 3D model is created layer upon layer from the bottom up. Stereolithography is a boom to industry because the prototype that used to take months to make will now take just a few hours. In business, in manufacturing, they have a design that they cannot evaluate it until they make the prototype weeks down the road after the first design concept. And then they come to their meeting with the head of the department, and he looks at it and he said, that isn't what I did. And they have to go back and spend all that effort with our system. You get it the next morning, and the same group comes together that next morning. Doctors at the UCLA Medical Center are thinking about using stereolithography for cosmetic surgery. For example, if this were my skull, I could ask the computer to redesign my jawbone, my cheekbones, my nose, my brow, whatever. And then at the push of a button, I could stand by and look at the new me rising above the liquid polymer. Stereolithography is now being used to design jewelry like these fancy rings, perfume bottles like this one recently made for Avon, and computer products like the outer casing of this Macintosh modem.
With stereolithography, you don't have this product is made with no machine, no tooling, and no layout drawings for a machinist to read.
So does this make a big difference to applicants?
It helps us get products to market faster, and it also helps us make better products.
Stereolithography turns human ideas into something tangible, and its future applications are limited only by the human imagination.
Well, I think the technology is capable of what I call just-in-time manufacturing, which is what is proven to be like it, which means they even produce the part just as you need it. Now, we're not there yet. We've probably got 5 years more of hard research and development, but think if we can make a whole car door in less than a minute, tooling and changing, like just changing the computer model, I think we can revolutionize the way the industry works.
So, as you can see,
See how science takes this
it's kind of embarrassing because if you look at the model quality that the parts that they were pulling out, compared to what we have nowadays, we've almost taken a step back for what we can do now from what they could do in the late 80s. It's a little bit embarrassing, but this is like one of the big reasons why you're gonna see a boom in the laser sintering, because those parts, they looked awesome. The fused deposition modeling definitely has a home in the future of 3D printing. It has a home in pretty much everyone's home, I think. And it's going to get pushed in that direction, I feel, because companies have invested so much money in making the better spool, making the better quality thing. It's when you look at the original debate when we saw like HD video, HD DVDs versus Blu-ray. Well, they were both really good. Blu-ray won because they got everyone hooked on it faster. Didn't matter if HD video was the better technology. Same thing can be said about the beta versus VHS. If anyone remembers beta and VHS, there was a huge debate about it, about which is going to be the better. Well, beta was the better technology. VHS got out there faster, and so.
Like even with HD video, we still went back to low standard definition or low definition for streaming video because mostly people wanted to, after they got this high definition stuff, they still wanted faster streaming.
Yeah, exactly. And they didn't want necessarily all the glitch of the digital, or they didn't want to wait for the videos. Like especially when you go and stream something on YouTube, anyone that's streamed HD videos on dial-up or tried to, even slow high speed, right? It's painful, right? So there's always a market, but I mean, what you're going to see in the future is you're going to see more fused deposition modeling before the laser sintering ever gets taken off. I really hope it takes off because I think it's the better technology. Any other questions? I'm just going to throw in a quick video of the non-Cartesian 3D printer so you can see another type of 3D printer printing. So this is a Rosoc non-Cartesian Delta bot. As you can see, a couple less moving parts, doesn't have the XYZ axis. And this is just doing its calibration to show you how level it can be. So if you could see, you'd see that needle isn't moving at all. Because it can print ridiculously fast, ridiculously flat. The biggest difference between this and a Cartesian printer is that it's limited in the area it can print. It usually prints in circles because of how it's plotted, and it uses a lot more physics to figure out where the nozzle is or where it should be. But like with most things that have been developed, it's already to a point where you really just load your print in, hit a button to make it into a digital model, hit another button to print it out, right? So you can see the circle pattern that draws there at the end. That's pretty much its physical restriction. So a friend of mine has a giant one that stands about this big. He can make things, I think it was just over 1/2 meter tall, but only, I think, 300 millimeters wide, so 30 centimeters wide. Yes, sorry.
There's a student, I think she's at MIT,
Yeah.
who's working on industrial scale versions using concrete. So she's actually working with pulleys
Yeah.
and trying to develop a system that will extrude concrete on the scale that you can put a building up before.
Yeah.
And it was a really neat concept, but I'm just wondering how far that project is.
China already did it. China already did it. Yeah. So to test how great it was too, so they've been working on it for the past 4 years. To test how great it was, 2 months ago, they decided to put up 10 single-story buildings, single-room buildings in one day, and they did it. The problem is we don't know how good the quality is, not just because of Chinese, but because, sorry for the joke, but because we don't know what it's going to weather like, right? So they're using a mixed substance of both concrete with a couple other materials. They have to remove a lot of the rock so it doesn't have the aggregate that needs to stay firm or solid for long amounts of time. So we don't know the longevity of that substance, but their idea and thoughts, and of course they've already patented the crap out of it. So I mean, really, it's like even if someone is working on it right now, they're to the slave to that company.
Do you know how to handle the set times and the potential for rebar reinforcement?
Yeah. So like so when it puts it down, it puts down the outside bits, and then it does a zigzag pattern for the infill. And then a guy walks behind and puts in the rebar. And it's just single piece of rebar all the way around. So
it's not completely automated, but it's still quicker than.
yeah.
Do you know the name of the product or the company that?
No.
Do any follow-up research on this?
No, I could definitely post something if you come. I was going to hand out cards because I have a webpage and a blog, but I can put something on my blog about it,
Okay.
so you can take a look. It's think3d.ca is where my store and blogging.
And hyphens or spaces.
Oh, think3d.ca. I hand out cards if you want. I bought pretty cards. They're really pretty. Okay. Any other questions about 3D printing?
Did you 3D print your cards?
No, because I thought that I honestly I was going to, and like my mom was like, "Oh yeah, 3D print the cards definitely," and I was like, "I don't carry cards as it is, like regular cards, like people having cards." I'm like, "No, if it doesn't have a web space I can remember, no." If I was a 3D printed card, unless it's somehow useful to me, I am definitely not carrying that thing around with me. I barely carry a wallet. Like I mean, yeah, but they're pretty and embossed. I mean, that's.
You can put a lighter inside them.
Yeah. Yeah, totally. Make it
Do
burn
something,
things.
right?
Yeah. I really my printers. I really am trying to market them to schools, to educational facilities, to the libraries, and to people. Like I've sold them just to people that want to get into it. They're really easy to maintain. Like I've made an open concept, so just to give myself a shameless plug about my printer. You can definitely come check it out. Or if you want to build printers, I have all the parts. Most of the parts that you need are on my store. So, and of course, I have plastic, lots of plastic. Any other questions?
Sorry. I was just going to say the name of the company that built those houses. That's what you were looking for, right? Windsun Decoration Design Engineering. Windsun Decoration Design Engineering.
Okay, great.
Glad they made it easier.
Yeah.
So it's Kriska.